Okay, so in this tutorial, I'm going to go through how you should be writing up your practical report. So this is based on the investigation handout that is up on Moodle in the assessment details folder. Firstly, you need to include an aim. So what is the purpose of your investigation? What were you trying to determine by looking at whichever rate of osmosis or a limiting factor that you were looking at? You then need to include a hypothesis. Remember that a hypothesis is an if-then statement and should be no more than 1 to 2 sentences long. You then need to include the independent variable. Now, obviously, this practical is on seed germination, so you need to make sure that you include all the appropriate, details on your osmosis practical. So this is just to give you an idea of what should be included. So the independent variable is the variable that you changed, and the dependent variable is the variable that changed as a result of changes to the independent variable. And in most cases, it was a change in mass, which indicates that there was some form of osmosis going on. And then you need to also include at least 3 different controlled variables that should be kept constant, and you need to explain why they should be kept constant. Now, because you did design this practical, you need to include a very detailed and full list of materials that you used, okay? So you need to start from a blank canvas, assume you have nothing, and you need to write that list with as many things and the right quantities of items that you used. You then need to include a method. Now, most of you have already submitted a method for part B of the practical, and you may then change that because you may have changed your method when you were actually doing the prac, but you need to include a method, which is a step-by-step guide about how you conducted the practical. What did you do? And it should be written in past tense, and you should not include any personal statements. So don't say, we measured the solutions, say the solutions were measured, okay? Moving on to the results section, you should include a table here looking at, that should be very similar to the table that you drew up for part B, and you need to include a title for that table explaining what the data in the table actually means, okay? And if you don't quite get this in the draft, I will be giving you some feedback on it, but hopefully you understand what I mean when I say a title. Now, this table here is this is just an average. I would actually like you to include the raw data, so all the trials, and then an average at the end. And the average is what you're going to be graphing as a graph. Now, you can just graph this on pen and paper or pencil and paper rather than using Excel, because I would like to see that you all know how to draw a graph. So if you're having any issues with graphing your results, please let me know this week so that you can submit a drafted graph by Friday rather than me having to then tell you what to do because you didn't submit it because you didn't understand. When you graph your results, again, you should have a title on the top of the graph explaining what the graph is actually showing. And when I say that, I don't mean temperature versus rate of osmosis. I would like you to say the effect of varying temperatures on the mass lost by potato cubes or something along those lines. So be detailed with your title. You need to make sure that you include units on your X and Y axes as well as a label for those axes. So if your concentration was in percent, you would have concentration of sodium solution in brackets percent. And then whatever you chose to measure the rate of osmosis. Okay, so moving on to the discussion, the first thing you need to do when you in your discussion is to describe the trend that you see. So is there a trend in the data? And when I say trend, I mean, is there a pattern? So we can see here that as you increase in concentration of Aquasol, you see an increase in the shoot growth of the radish seedlings. And then we see what we call, I guess, a peak growth rate, and then as you increase further in concentration, it actually starts to decrease again. That is a pattern of results, and you need to do the same when you're looking at your rate of osmosis or the amount of mass that is lost by your potato cubes. So you need to describe very clearly the data represented in this graph as if the graph wasn't there. So I should be able to visualize what this trend in the data on your graph should look like based on your description of the data. So be detailed when explaining. Now, the second part of your discussion is you need to explain what the data means. So this is explaining why you saw the pattern of results that you did. So in this case, the reason why we saw an increase in the rate of shoot growth as we increased the concentration of aquasol is because there were more nutrients readily available for the seedlings, and therefore they were able to grow quicker and better. However, if you get too much if the fertilizer is too high, you actually get a decrease, and the reason for that is because there was fertilizer burn. So you need to explain, why do we see an increase in loss of mass of the potato cubes as you increase in temperature or surface area or concentration of salt? So you need to explain why, okay? Because that's what science is all about. It's why. Now, this is the next stop point is you need to talk about how well you held the three constant factors that you mentioned above. How well were they actually maintained? So this is often represented in the scatter in your data. So you had all those trials, and what you would have noticed is that not all of the trials would have been the same. Some of them would have had slight variations in the results or the mass recorded, and that means that you didn't actually hold the size of the cube as well as you thought you did. Okay, and you need to explain that. And you also need to think about how that might impact on the data as well. Okay, so think about what that might have when you're trying to measure osmosis. Now, the next step is identifying random and systematic errors. I would like to see from all of you 2 random and 2 systematic errors. When you identify, so the process of, I guess, discussing a random error is you need to start with firstly identifying the error. So this person here has said a possible source of random error may have been a variation in size of the radish seeds. Okay, so she has identified the error. Then she's gone on to explain, well, how does this actually impact the results? So apparently, larger seeds have been shown to have a greater percentage of germination, seedling rigor, and shoot growth, which means that the larger the seed, the more shoot growth you would expect to see, regardless of the concentration of fertilizer. So that's how it impacts on the results, because what this means is that seeds should have been remained constant because we want to know how fertilizer is impacting the results. But because the seeds were different sizes, we have a second independent variable because seed size now impacts on shoot growth. Okay, so that's how that error is impacting the results. Now it's impacting them randomly because not all seeds were larger or smaller. They were randomly assorted seeds. Now the student has then gone on to suggest an improvement to the method that will hopefully eliminate or reduce the error. So she's suggested that to reduce the variation, an improvement would be to use a slotted sieve of a specific size. That would mean that when you sieve your seeds, only a certain size seed will be able to pass through the sieve, and therefore the sizes of the seeds should all be roughly the same, so that we're just looking at the concentration of fertilizer on shoot growth. Okay? And I've identified another one here. So identify the error, explain the error's impact on the results specifically. So don't just say it's going to make it less accurate. That's not very descriptive. I want you to say specifically how and then to suggest an improvement for that error. All errors that you identify must have an improvement in the same paragraph. Okay? And then, so random errors are human errors. They affect the results randomly, whereas we know systematic errors affect the results all the same and are usually to do with the accuracy. So we've talked about systematic errors before. It's usually incorrect calibration of equipment, incorrect measuring, and it's all about, it's actually a little bit further away from the true value than what we thought, okay? And the same process is involved with your systematic errors. Identify the error, explain how it impacts on the results, and suggest an improvement. And then finally, the conclusion. So in the conclusion, you should clearly summarize the uh, overall results. So in this case, they saw an increase of growth of shoots as the aquasol fertilizer increased in concentration until it roughly 60%, and then you had that started to die off because of fertilizer burn. You then need to state whether the hypothesis was supported or refuted. Remember that a hypothesis is never proven, okay? The results support the hypothesis. We cannot prove a hypothesis by saying, oh, we found some results that we said this was going to happen and it has. That's not proving, that's just supporting, okay? And then you need to link it back to the concepts of biology and whether you observe what you expected to observe. So I expected, or for example, I understand that as surface area to volume ratio increases, you should see a larger rate of osmosis, and that was reflected by the results in the practical. Okay?